When you read a sentence, you don't read it letter by letter. Your brain automatically groups individual characters into recognizable, meaningful words. A compiler operates exactly the same way. The engine that actually analyzes your code, the parser, cannot process raw, unbroken character strings. It needs the text chunked into meaningful pieces. That chunking is the job of the Lexical Analyzer. This is phase 1 of the compilation process, acting as a dedicated translator. Without this initial translation, the parser is blind to the structure of your code. The Lexical Analyzer bridges the gap between your raw keystrokes and the structured grammar the machine requires. To bridge that gap, the Lexical Analyzer performs 4 silent tasks. It strips out your spaces, removes your comments, detects typos, and generates tokens. This table shows exactly how that generation works. The lexeme is the actual text written in the source code, like the word age, the number 100, or the command F. The token is the abstract category that text belongs to, identifier, number, or keyword. To match a specific lexeme to its correct token category, the lexer uses a rule called a pattern. For example, any text starting with a letter, followed by any combination of letters and digits, fulfills the pattern for an identifier. Tokens are the vocabulary the compiler understands. Lexemes are the specific words you type, and patterns are the dictionary rules that connect the two. Here is a visualization of that connection happening in real time. The lexer scans the raw source text strictly from left to right, evaluating one character at a time until a specific pattern is fulfilled. It groups TOTAL, recognizes the identifier pattern, and packages it into a single token data block containing its category and value. When the scanner hits the space immediately after the word, it drags it entirely. White space is cleaned up on the fly so the parser never has to deal with it. The scanner sweeps through the rest of the line, identifying operators, a second identifier, numerical constants, and delimiters, outputting them sequentially into the token stream. Simultaneously, as the lexer discovers these new variables, total and marks, it logs their names into a master ledger called the symbol table for later use. This automated process takes an unformatted, chaotic string of text and structures it into a predictable sequence of data packets. The parser now has exactly what it needs to check your grammar. Let's put this to the test. Pause the video and write down the exact token stream output for this while loop condition. Here is the correct translation. Notice how the lexer isolates while as a key word and clearly separates the parentheses as independent delimiter tokens. If you can manually predict this sequence, you understand how phase 1 of a compiler processes code. The lexer is a frontline security guard, catching lexical errors. If an identifier starts with a digit or uses an unsupported symbol, the scanner rejects it. Forget a closing quotation mark, and the lexer recognizes the structural gap right away. Catching these foundational typos at the character level ensures the syntax analyzer doesn't try to parse broken logic and cause a cascading failure later on. To summarize the data flow, raw characters enter, spaces and comments are destroyed, patterns group the lexemes, tokens are generated, variables are logged, and a clean stream of data is handed to the parser. But this raises a mechanical problem. Reading a million-line source file, one character at a time from a hard drive, would be incredibly slow. How does a compiler execute this scan without destroying system memory and performance? We cover the mechanics of input buffering in the next part. For now, remember the absolute core function of lexical analysis. Characters enter, and tokens exit.